Hey fifth graders, we are going to be jumping into our dividing fractions unit, and we're going to actually start off by taking a look at dividing by unit fractions. So we're going to kind of start off small and then we'll get more complicated with the types of fractions and numbers that we're going to deal with. So today we're going to go ahead and we're going to divide whole numbers by unit fractions because it's really important for us to understand how many unit fractions make up a whole thing. So remember, with division, so we're going to go back to like third grade train of thought. What we're trying to figure out is how many times the divisor fits into the dividend. Now let's go ahead and define those two words. So remember, the first number in a division problem, that is your dividend, because that is the number that's going to be split up. Your divisor is the number you're splitting it up by. And your answer is what we call the quotient. So in this example in particular, we're trying to figure out how many times 4 fits into 20. And what we're going to find is that it fits in 5 whole times, which is why that is our answer. Now there's other ways to think about division, but we're going to use this train of thought for today because it's going to help us with our unit fractions. So what is a unit fraction? I've said that word twice. Let's define what a unit fraction is. If you notice, the stem of the word unit is uni, and uni means 1. They are fractions with a numerator of 1. So we're going to use the same train of thought about figuring out how many times your divisor fits into your dividend to solve these types of problems where we have a whole number divided by a unit fraction. So what we're trying to figure out in this particular example is how many times 1/4 fits into 3 whole things. So let's draw a picture to get an idea. So I have 3 whole things here. I'm going to start with just one of them, and I want to know how many quarters will fit into one whole thing. Well, let's split this up into quarters and see how many of them fit in. Well, 4 of them, because 4 quarters makes up one whole thing. So here's 1/4, 2 quarters, 3 quarters, 4 quarters. So this is 4 quarters. And then we look at our second thing, our second whole thing. 4 more quarters fit into that. So now we're looking at 5, 6, 7, 8 total quarters. And now when we look at 3 whole things, we have 9, 10, 11, 12. We have 4 more, which gives us a grand total of 12 quarters. So we can actually just use our knowledge that 4 quarters fits into one whole thing. We can use that because if instead of looking at one whole thing, we're looking at 3 whole things, we can go ahead and multiply that number by 3. I'm going to triple that because I don't have just one whole thing, I have 3 whole things. So it turns out that we have 12 quarters that fit into 3. So this may seem a little bit weird because when you were younger, when you had division problems, such as this one up above, your answers, your quotient used to get smaller, right? 20 divided by 4, the 20 got smaller and became 5. That's how you normally think about division, about things getting smaller. When you think about multiplication, they get bigger. That's when you're dealing with whole numbers. When you're dealing with fractions, however, some different things start to happen because fractions are not whole things. They are part of a whole thing. So really what we're trying to figure out is how many times this itty-bitty thing of a quarter fits into 3 whole things, which is much bigger than the quarter. So you're trying to figure out how many times this really tiny thing fits into a bigger thing. And it turns out the itty-bitty thing is going to fit in like a lot of times, which is why your quotient got bigger. Let's take a look at a number line, how we can solve some of those, or some of these types of problems where you have a whole number divided by a unit fraction. So I have 2 divided by 1/6. So my goal is I want to know how many, I should write this out, how many 1/6 fit into 2 wholes. So we're going to use a number line this time because that might help some of us understand this a bit better. So let's take a look. We have 0, 1, and 2. Now, remember, when we're trying to figure out what our tick marks represent, we need to look at 1 unit from 0 to 1 if possible. Or again, if my number line had been from 1 to 2, that's a distance of 1, so that's your one whole thing. And how many parts is it being broken up into? 1, 2, 3. So I'm actually dealing with thirds. I don't want to deal with thirds because I want to think about this. I need to know how many sixths fit into 2 whole things. Now, if you remember back to our fractions unit when we were modeling them, we can turn thirds into sixths by cutting them in half. You take your 3 equal groups, you split them in half, because then I'll give 2 for each group, and 3 times 2 gives you 6. And now I have a grand total of 1, 2, 3, 4, 5, 6. So now I have created sixths. So our question is, how many of these sixths will fit into the 2 whole things? So we're going to use skip counting. So we have 6 sixths, so 6 sixths are making up our whole thing. And then we have 7, 8, 9, 10, 11, 12, because we have 6 more sixths that make up our second whole thing. So that gives us a grand total of 12 sixths. So if we break this down, how many sixths fit into 1 whole? Well, 6 of them. So if I'm going from 1 to 2, I'm going to multiply by 2. So the amount is going to be doubled, which is why we get 12. And again, some of you may be like, man, I thought with division we used to get smaller, and now my 2 is turning into a 12. Again, that's because you are taking a really itty bitty thing, and you're seeing how many times it fits into 2 whole things. And 1/6, because it's so itty bitty, it does fit in 12 whole times. Let's look at a couple more examples together. 5 divided by 1/3, we've got a number line and an area model. So what we need to figure out is how many 1/3s fit into 5. Okay, so I have 0, 1, 2, 3, 4, 5. The first thing I need to do, sorry, those should have arrows on them. The first thing we need to do is create thirds. So if you remember back to our fractions on number lines unit, to create thirds, we need to be off-centered. So we like to use that finger method, where you put your finger in the middle and then you do your tick marks to either side of your finger. And that'll, in general, create pretty nice thirds for you. So I'm creating 3 equal groups between each of my units. And these are units because it's a distance of 1. Okay, so now I've created thirds, and I need to count up how many of these thirds have just made up my 5 whole things. So I have 1, 2, 3 thirds gets me to 1. 3 more gets me to 2. So that's 3 thirds. 3 more gets me to 3. And hopefully you're starting to see a pattern here. 3 more get me to 4. Oops, sorry. 1, 2, 3 more get me to 5. So that is a grand total of, so we had 3 thirds, 3 thirds, 3 of them, 3 of them, 3 of them, 3 plus 3 plus 3 plus 3 plus 3. Well, that's repeated addition. That's the same thing as 3 times 5. That was 15 thirds. That was 15. Let's double check our work by using an area model. So I have 5 whole things. I'm going to go ahead and split these up into thirds. Remember, they need to be a little off-centered. Here's 1/3, 2 thirds, 3 thirds makes up 1 whole thing. 4 thirds, 5 thirds, 6 thirds, 7 thirds, 8 thirds, 9 thirds, 10 thirds, 11 thirds, 12 thirds, 13 thirds, 14 thirds, 15 thirds. 15 make up 5. We can use a little bit of a shortcut because we know that we have 3 thirds makes up 1 whole. Well, I'm trying to look at 5 wholes, so I'm going to go ahead and multiply that by 5 because I have 5 sets of a whole thing. So I can go ahead and multiply this by 5, and we get the 15 like we had modeled. So hopefully that's the pattern that you've noticed. When we're dividing whole numbers by unit fractions, we multiply the denominator by the whole number. All right, let's look at some examples together. So I have 4 divided by 1/2. I want to know how many halves fit into 4. So I'm going to cut all of these in half and then count up how many of them made up the 4 things. 1, 2, 3, 4, 5, 6, 7, 8 halves. 1/2 fits into 4 8 times. I want to know how many eighths fit into 3 whole things. Well, let's see. We know that 8/8, 1, 2, 3, 4, 5, 6, 7, 8 of them fit into one whole thing. 8 more will fit into the next whole thing. And 8 more will fit into the third thing. So I'm going to have 8, 8, and 8. That is 8 times 3, which is 24. So you can go ahead and label these. You can continue counting if you'd like to. But I think at this point it's very clear. 1, 22, 23. There you go. There's your 24th eighth that is fitting into 3 whole things. 2 divided by a quarter using number lines. So the first thing we need to do is let's split this up into quarters. Cut it in half and cut the halves in half. 1, 2, 3, 4, 5, 6, 7, 8. 8 skip jumps means that 1/4 fits into 2 8 times. And then 6 divided by a half. I want to know how many skip jumps of a half will get me up to 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 halves fit into 6. So again, if you notice, really what we're doing is we're taking our numerator, or excuse me, our denominator and multiplying by the whole number.